So we're here to talk about some of the components that bring the water from the roof to the cistern. So we have our metal roof. It could also be maybe asphalt shingle. It could be different types of metal. It could be wood shingle. So there's different types of roof materials. Typically the cleanest type of roof is a metal roof. It's the most efficient getting the water off, and it tends to not shed any other debris of the roofing material, such as wood or asphalt. We have, again, the snow cleats, the little round snow cleats on the roof to hold the snow up on the roof and let it slowly melt and go into the gutters and into the cistern instead of sliding off and pulling our gutters off. The gutters also have a leaf screen to keep out big debris, leaves, pine needles, any kind of large things that could clog up the downspouts or the pipes on the way to the cistern. Then the gutters go in to one side, so they're sloped about 1/8 of an inch per foot grade to one end, and then you have your downspouts. Here in the corner, we have a downspout going down in the corner there, collecting. So this roof here dumps onto this small roof. And your upper roofs don't really need gutters. See how the upper roofs don't have gutters? They just dump onto this lower roof, which is all caught by the gutters here. Typically, you want to have at least one downspout for every 30 to 40 linear feet of gutter. The gutter comes down, and then you need to convert from the metal downspout to typically a plastic pipe. So it could be a corrugated flexible pipe, 4-inch, or what we typically use is a 4-inch S&D pipe. So S&D means sewer and drain, right? So it's a thinner wall pipe because it's not pressurized, right? It's all gravity fed water, just draining, right? So that's the pipe that you usually use for like a sewer or a drainage system because it uses less plastic. Typically 4-inch pipe. If it's a larger system, if you're capturing over maybe 4,000 square feet, then you usually need to upgrade at the end of the piping system to a 6-inch. The conversion fitting from the downspout to the pipe's round and the downspouts rectangular, right? So there's a certain type of fitting that's like goes from round to rectangle. And so you can buy those at just a big box store or your local irrigation, drainage, or plumbing store. The 4-inch plastic pipe goes into the ground and then needs to elbow, so it needs a turn, and then start going horizontal. At the best is a 1/4 inch per foot slope. You can go as minimum as 1/8 per inch slope per linear foot, because that water needs to drain, right? Gravity drain to the conveyance filter before the cistern. With roofing types, they all have a different, what's called the runoff coefficient. So that's why I said earlier that the metal roof is kind of the most efficient roof because it's smooth, and it doesn't absorb water, and it stays clean, right? So the higher the runoff coefficient means the more efficient it is to delivering water off the roof. So if it's a wood shingled roof, imagine that those cedar shakes or wood is going to soak up some water. There's different ways to filter the conveyance water, the water coming off the roof to the cisterns. One way is called a first flush diverter. So that is taking the first water off the roof, a percentage of the water, separating it from the clean water. So the dirty water is separated first. Typically it's a T and another pipe that's along the side of the downspout that diverts the first flush, the first dirty water, and then that fills up, and then the water that's coming after that is the cleaner water. In the cold climates, we don't really do first flush because they tend to clog up and freeze and break. But in warmer climates, places that doesn't get much below freezing, Southern California, warmer areas, you could also do that first flush application. There's also another product called the leaf eater. So that's where the downspout comes, and then there's a gap, and then there's a piece that fits on the lower piece of the downspout. So the water comes out of the downspout and then goes through a screen to continue down the downspout. Any kind of debris or leaves or anything like that kind of wash off the screen. We typically just do the gutter screens and then the pre-filter before the tank, the conveyance filter before the tank. So when the pipes come to the cistern or leave the cistern, there's two types of fittings that we typically use. One is a gasket that is not waterproof, but just basically keeps the dirt and any insects or anything like that. It's a tight fitting gasket around the pipe. Typically it's a 4-inch pipe going into the tank. That would be where maybe the conveyance line, as after it goes through the filter and it's going into the tank, because your conveyance line always wants to come into the tank slightly above your overflow, so that it's dropping into the tank, and then the overflow can be anything from 1 to 4 inches lower than that, so that the conveyance pipe is always clear and it's not holding water to freeze. Any fittings from the overflow and above can be just the gasket, so it's a rubber gasket that you can find for 3-inch pipe or 4-inch pipe. And then there's the other type is the waterproof fittings, and they're called bulkheads. So you can get 1/2 inch, 1 inch, 2 inch, 3 inch, 4 inch bulkheads, or for pipe, bulkheads that fit those different size pipes. And those typically, they have a large nut and a gasket on both sides, and you tighten them down, and that creates a waterproof fitting. So when we tie these tanks together in the bottom of the tank, we would use a bulkhead so that they act as one tank. They're tied together in parallel. Any fittings below the overflow needs to be waterproof. So if the tank fills up, those fittings are underwater. And think about when you put these cisterns in the ground, even though you're going to compact the soil below the tanks and get it settled as much as you can, the tanks are going to shift slightly in the ground over time. What we usually do to tie the tanks together is we use a flexible 2-inch pipe, so that if the tanks move a little bit, that pipe can move with it and not just be a rigid pipe that could possibly break. So you always want to plan for when your tanks get full. My tanks are full right now because it's early spring, and my tanks got filled up with rainwater all winter long. So you always want to think about your overflow and then have a beneficial use for that overflow. Maybe some swales or some basins or oasis plants that like water at your overflow. That overflow pipe, it's where the tank is full, so you don't need to have that connection be waterproof. You can just use a regular 4-inch gasket for that pipe. That pipe needs to drop about 1/8 of an inch of a foot out of the tank to drain that water away, and so it doesn't hold water and freeze. Also, with above ground tanks and below ground tanks, you want to make sure that any inlet or outlet, so the overflow or any inlet pipe, are screened. So you want to keep out mosquitoes from getting in and laying eggs. You want to keep out critters or anything that could crawl in and possibly drown in your tanks. So you always want to screen your overflow and then plan for a beneficial use for that overflow water. Underground or above ground tanks can be made with many different types of materials. Above ground tanks could be metal. I've made them out of culvert standing on end. There's metal in a silo, like galvanized metal tanks. I've built plenty of ferrocement tanks, so you can actually build tanks that are very thin-walled with wire and cement. The tanks that we typically use in the Southwest, because labor is expensive, is polyethylene tanks. So that's PE or polyethylene. That's the cleanest kind of number 2 plastic, what you would get when you buy a jug of milk in a plastic jug. Those are some of the main above ground tanks. Below ground tanks are typically polyethylene if they're plastic. There's also fiberglass tanks. There's cement tanks, or you could actually build your own underground cement tank, or you can buy even septic tanks and put them in. But the septic tanks, typically, they're harder to retrofit into a series of tanks, right? Because they only have the inlets and outlets at the top. Typically, it's better or more cost efficient to use polyethylene tanks underground, unless you're going to build your own tank and plaster it yourself. There's also tanks that are actually large plastic bags or fabric plastic mesh bags that you could have under your house or in a crawl space. They're called pillow tanks. So there's different sizes that you can do, or they could even be maybe underneath a deck. There's a lot of new narrow and tall tanks that are above ground that can be put together as to form like a trellis or a wall. or a fence. I always encourage, if you can go out and find used tanks, are great, right? Old water tanks off of ranches or maybe out of dairies, or some reusing of those materials is recommended. How do we get this water out of an underground cistern? Maybe you're capturing the water high in the landscape, and then you have a pipe out of the cistern that's high enough to a lower use, you can use gravity. But typically with an underground system, we're using a pump. There's two types of pumping systems. One that is initiated or activated by demand, right? So it's usually turned on and off by an irrigation controller. So the irrigation controller has a wire to a pump relay switch that opens and closes the power to the pump. So when your irrigation system turns on and says, I want water for zone 1 or for the vegetables, it sends a signal to the pump relay switch that gives power to the pump. And the pump turns on at that point and delivers the water to the irrigation system. The downside of that is if you have any spigots in the delivery pipe, those spigots won't work unless you turn on an irrigation controller. Most of us are used to pressurized water. Second type of pumping system is a pressurized system. So the pump builds up pressure in the pipes until the pressure switch says, okay, that's enough pressure, and it cuts the power off to the pump. And as soon as the pressure drops below whatever the pressure switch is set at, right? So you might have set it to turn off at 60 pounds of pressure and then turn the pump back on at 50 pounds. So if you open the spigot, or an irrigation zone opens, the pressure drops from 60 pounds down to 50, and then all of a sudden the pump kicks on and starts delivering water again. Then when you stop using the spigot or stop using irrigation, the pump continues to run until the pressure goes up to where the pressure switch is set, and then the pressure switch cuts the power to the pump. So that means that the whole system is pressurized the whole time. As soon as the pressure drops, that kicks on the pump. The benefit of that is that's the water we're used to, right? We're used to opening a spigot or opening a valve and the water comes out. The downside is if there's any leak in the system, then that leak could possibly be happening all the time because the pump is always trying to build up pressure. And if there's a leak, then the pump might cycle on and off if there's a leak in the system. The downside of the on-demand system that's controlled by the irrigation is that you would need to turn on the irrigation controller to supply power to the pump. The benefit of it would be if there is any leakage in the system, that leak would only be happening when the pump is on, when the irrigation controller is saying that the pump should be running, right? So if there is any leak in the system, you possibly would be leaking less water in that type of system. We talked about the pressure switch. That opens and closes the electrical connection to the pump, depending on what pressure it is in the system and what the pressure switch is set for. I am using, in most systems now, a submersible pump that has a built-in pressure switch, or you can also have a pressure switch that's separate from the pump in a different control unit box with a pressure tank. So the pressure tank allows the pump not to cycle so much. So the pump turns on and it builds up pressure in the system, and then it fills up that pressure tank and then turns off. The pressure tank is like a buffer so that the pump doesn't turn on and off if you just open the spigot a slight amount. Or if you had this going back into the house and domestic water use, when you're brushing your teeth or washing your face, instead of that pump going on and off every time you open the spigot to brush your teeth, you have that water in the pressure tank that keeps the pressure at a certain level until that tank is empty, then the pump goes on. So pressure tanks tend to extend the life of the pump and keep it from cycling on and off too many times. So the cistern pump is delivering cistern water from the tanks to two spigots on the way to the irrigation system. This is the irrigation box with the irrigation valves, the filter. So the cistern water comes into this box, and I can choose to have that valve open or closed, or have the well water be open or closed. The rainwater then comes through this pipe and then delivers cistern rainwater to these 5 different irrigation valves that go to different parts of the garden. Valve 1 goes to the lower terrace, valve 2 the middle terrace, zone 3 or valve 3 goes to the 3rd terrace, Valve 4 goes to the 4th terrace, and then valve 5 goes to my veggie and annual beds. So my raised beds and any kind of vegetable annual beds.